This video took me far too long to make. All I wanted to do was explore how to invert a binary tree using classes in Julia. I had to take a deep dive into structs and mutables and all sorts of things to do that. Nothing, I had to look at what the nothing was defined as in Julia, just to bring you those mistakes that I made so that you don't make the same. My name's Chris and that's what this channel is about, helping you learn Julia so that you don't make the same mistakes that I do. So in this video, I'm going to look at defining a binary tree in Julia and then inverting it, which seems to be a common interview question that some tech companies ask. So it's taken me back a bit to my university days because it's been a while since I've defined a binary tree and inverted one. It took me over an hour to get this example ready for this video, so I hope you appreciate it. The first thing we're going to do is define our mutable struct as a binary node, because any node in the tree can be its own tree. So within our tree, we're going to have a name, which is a string. We're going to have a left side of the tree, which is going to be a union of binary node and any. Now, originally, I had this as a union of binary node and nothing, but for some reason that doesn't seem to work, and I couldn't figure out why. If you know why this doesn't work, please leave it, and you're thinking ahead, please leave a comment below. But for now, we have to set it to type any. Now, what I'm saying here is that for each binary node, there is going to be a left and a right within it. The left can be of type binary node, or it could be of type anything. Now, I wanted it to be of type nothing because our left can be nothing. That's when we know we've hit the bottom end of the tree. And if our right is nothing as well, we know we're strictly at the bottom. However, I couldn't figure out how to make this union on type nothing. So that was the bit I got stuck with for so long. So please leave a comment below if you know how I should do that. Otherwise, we'll stick with it being nothing. We'll stick with it being anything. So hit end there, and we're going to define our access to our binary node. So if you get a binary node, if you ask for the name of a binary node, you get the name. This is actually optional for this one. If you take the left of a binary node, you get the lefts. So this is a hangover from when I defined it as an equivalent to classes. So if you're familiar with Python and you're looking for what a class is in Julia, Julia uses structs instead. It's not an object-oriented language, so you can't create new objects. There's no such thing as new in Julia. You can use this struct approach instead if you want to keep structured data together. And so we're going to define that here, a mutable struct. Mutable means we can change what's inside the struct with a function. And then we define what type of objects go within, or what type of things go within the struct. Okay, so we've got our generics there, and now we're going to define our function. So I've got my notes on the previous screen. I spent so long putting this together that I do want to refer to my notes to make sure I'm not making the same mistakes again. Okay, so we can define our push function now. So push, now the exclamation mark means that the function changes some of its arguments. So this is name of type string. And then we put in if name is less than name. If it goes on the left again, then we create a new binary node of name nothing nothing because it's got no children at this stage. If equals, if n dot left equals, I've made this confusing for you, sorry. N dot left equals that. So now we go down here, we say else push n dot left into n dot left name, and else if name is greater than n dot name. So for this binary tree, if the name is the same, we just ignore it. So n dot name, if n dot right is nothing, then n dot right should become a new binary node with name and no children. Otherwise, we further go down the tree to the right hand side and put name in. Okay, now I believe there's a way to do this with a loop. However, when I learnt binary trees back in university, we always did it recursively. Now that might have been because it's C that I learned to do this in, a different programming language. So if you know the answer on how to do it with loops efficiently in Julia, please leave a comment below. And I can make a revised video on how to do it with loops. So we've defined our push function. Now we also want to define a print function so that we can print out our whole binary tree. I've done it recursively as well. So function print binary tree takes a binary node, and a string. And if, okay, so we print line our current, oops, just copying and pasting there, and I've missed what I was copying and pasting. So we print line n.name, and then we can do if there are children to the left, so it does not equal nothing. Then we should print the tree of those children. Oops, what have I done? Okay, and if there are children to the right, equals nothing. Then we should print those children to the right. Okay, so now that we've defined how to insert items into a binary tree and how to print a binary tree, let's define our binary tree. So we started a root node, which is just a binary tree node, which contains a name and two children, which we're going to call nothing and nothing at the moment because it's by itself. We're going to add things to it later on. And for the name, I think I'll pick Shake, which is, you'll see in a minute, but this is what I had for dinner recently. Shake. Okay, so now that we've got our root node, we can push items to it. So push to root, we're going to put in Shack. That's what I had for dinner yesterday. Then we're going to push into root burger, because a Shake Shack burger is what I ate. We're going to push into root Thai, because I had Thai tonight, a very nice Thai curry. And then we're going to push in one more. Let's be a bit healthier this time, and let's say salad. Okay, push in salad, because I'll get in trouble if I'm not eating enough salad. Rightio. So now we can print the tree, print our binary tree, starting at the roots, and you can see that all these items have come out: Shake Shack, burger, salad, Thai. So salad has ended up over there. Yep, okay. So what it's done is Shake Shack, burger, salad, Thai. It hasn't printed it in a nice tree format, but unfortunately, because it took me so long to figure out the nothing in Julia, I didn't have time to make this print function a bit prettier. If you've got any suggestions on making it prettier, please leave in the comments below. Now we're going to do our inversion. So we've got our binary tree. Let's invert it. So we'll define a function to invert a binary tree, which takes a node of type binary node. And we look at if there are no children to this node, then we don't need to do anything, because inverting a binary tree is simply swapping the children with each other. So if there are no children, we return nothing because we've finished our inversion. Else, so if there is a child, we swap the two children nodes, and now one of them can be nothing when we're doing this swap. So n.right, and then if n.left does not equal nothing. So if the new, n.right equals temp. So if n.left equals nothing, we invert the left, and and if n.right is something does not equal nothing, we can invert the right. Okay, that's our inversion function. So we save that to the kernel. And now let's print our binary tree again so you can see what it looks like. And I'll also print root as the code. So you can see here we've got binary node of binary node of binary node, etc. And nothing's all at the bottom. So when you reach all nothing, you know you're at the bottom of the tree. Now we can invert root. And now this, because we've used that exclamation mark, and we're changing root, we're changing the tree. So we've inverted root. Let's try root now and see what happens. Because it looks a bit different, see? But we'll print it so you can see for sure. Print binary tree root. It's still a binary tree, we've just inverted it slightly. Oops, what have I done? Print binary node. Print, binary. Binary tree. Shake, Thai, shack, burger, salad. So it doesn't sound as appetizing anymore. I prefer the Shake Shack burger, the salad, and the Thai. But I'm sure I could deal with a Shake Thai, a shack burger, and a salad. So what we've done there is just invert the binary tree by swapping those items. If you've noticed any mistakes I've made, please leave a comment down below. I'll look to get back to you. Otherwise, if you've got any suggestions for the next video, anything you'd like to see me do, similarly leave a comment and I'll make a video on that. I've got some good videos coming up about how to do different operations like this in Julia, how to actually solve problems in Julia. So hit subscribe, follow along, and I'll be releasing those shortly. Hopefully I'll see you in the next video.